The broadcast is now starting. All attendees are in listen-only mode.
Hi everyone, welcome to today's webinar, AWS an Overview. My name is Michelle and I'll be helping with today's session. Before we get started, I'd like to review a few housekeeping items and let you know how you can participate. This webinar is being recorded. We will provide you a link to the recording as soon as it is available. You have joined today's webinar listening through your computer speaker system by default. If you would prefer to use your telephone, just locate your audio pane and select Use Telephone. The dial-in information and access code will then be displayed. Attendees will be in listen-only mode, and we invite you to ask questions about the presentation using the questions pane. Just type in your question and click Send. At the end of the webinar, we will do a question and answer session and take as many questions as possible. Now let me introduce you to our presenter today. Rich Morrow is a full-stack generalist with particular in-depth knowledge and love for cloud and big data technologies. When he's not flying around the country for global knowledge, providing training on AWS and Hadoop to the Fortune 500, he's probably writing or speaking about cloud, big data, and mobile topics for GigaOM. Thank you so much, Rich. Welcome, and I will turn it over to you.
Thank you, Michelle. Before we dig into the services at a deep level, I'd really like to go through the regions, the zones, and the edge locations, the global infrastructure that Amazon provides that makes it very easy and very approachable to do these scalable, highly elastic, highly available infrastructures. And one thing I do want to mention too, I believe Michelle said that we can take questions at the end. I'm very happy taking questions all the way through. So if you do have questions, please send those over chats. Michelle will be filtering them and then sending me questions as they come along. I think we've baked in probably about 10 or 15 minutes overall for questions. So if you have any questions as we're going along, please do shoot them over, and I'll try to address those as they come in. But if you could, please browse with me to this bit.ly link right here for AWS infrastructure, and it should take you to this particular link. This is just a set of slides I put together for another course that I taught, a video course. So actually, sorry, let's zoom back out here. Amazon has, this concept of global infrastructure. They started with US East in the US, and then they slowly added new regions in the US area, and then they, once they had that, they started adding regions in Europe and Asia Pacific, and now they have regions in South America. And actually, there's one in here that's still in beta. Beijing, right around it here, is up and running. Actually, I think it's closer to this blue dot, and it's in beta mode right now. So the great thing about Amazon is when you go to use them, you get immediate access to this global infrastructure. Whereas if this were your own infrastructure that you were spinning up, it may cost you $5 or $6 million each to build a data center in each one of these areas, and it probably wouldn't be as highly scalable and as fault tolerant and as cost-effective as Amazon. So one of the big things that Amazon has going for them is when they purchase really anything, when they purchase hardware or services like bandwidth and power, even real estate, so on and so forth, they can go into these countries and go into these companies for their suppliers, their vendors, and they can get these massive bulk pricing deals. So the dollar amount that they're paying per CPU or per server is probably way, way lower than you're able to get yourself. And Amazon has to date been extremely altruistic, so that when they get a price reduction, if, for example, their Sao Paulo power provider gives them a 10% discount or something, they've typically, rolled that discount up and passed it along to servers. They've passed that along to customers as well. So when the users come along to purchase a particular service or something in that region, they all of a sudden get that lower cost. So if we zoom into a region is comprised of several availability zones. And I've zoomed in here to the US East region, which now has 5 availability zones. It's the largest one available. Every region out there has anywhere from at least 2. Most of them have 3 availability zones that you can span your services across. An availability zone is essentially a data center. So if you're familiar with the concepts of a data center, a physical location that houses, a bunch of compute and storage resources, that's exactly what it is. So this availability zone A is a physical data center. Availability zone B is another separate physical data center. A region ties together many of these data centers via high bandwidth or low latency fiber. So typically, data transfers between AZs, between data centers, is free. There are a few services that will charge if you're moving data between services, but typically the data transfer is free and it's very, very fast. So it makes it a total no-brainer to do things like span a web server or an application server farm across two AZs, two or more AZs, and then you get this, physical redundancy of data centers. And if AZ-A goes down, everything will just flip over to AZ-B. And again, you have to set this up and you have to do it the right way, but Amazon makes it very easy to do that. So most of the services that you will provision inside of Amazon, like EC2, the virtual servers, or RDS, the managed database product, deploy to a single AZ. So when I deploy a service like this, I'm going to deploy it into a single availability zone, and my services will exist inside of that data center. Again, if there is any issue into that data center, if I don't have other services available, if I didn't provision other EC2 instances in other AZs, then I would lose my app. My customers would lose the ability to get to my app. So a really, really common thing that you want to do for HA is span your services across AZs. And Amazon makes that very simple. In the case of EC2, we have a concept of auto-scaling groups where we can take and maybe put 2 servers in this AZ and put 2 servers in another AZ, and then wrap them in a single auto-scaling group and balance the traffic across 2 individual data centers, 2 or more individual data centers. So the multi-AZ deployments are the preferred way to do the HA, or the high availability, inside of Amazon. They do have the possibility of doing multi-region as well, but that turns out to be a whole lot more cost, because you typically want your database to be close to your app servers and your web servers. And if you did a multi-region HA setup, you would need 2 redundant stacks, and you'd need to pay Amazon 2 times as much for your overall infrastructure. The other nice thing, or the other reason that you probably don't need to really do multi-region setups, is because each AZ has multiple independent redundant providers for their power and their bandwidth. So the chances of a single AZ going down at any time are pretty slim. But even if they did, Amazon gives you native capabilities, even in RDS. Setting up a replica, a slave, hot failover slave in another AZ is very, very simple. It's literally a checkbox in the web GUI. So if let's actually zoom out on this a little bit. If we look at an individual region, a region is a collection of several data centers or AZs. Each region, again, has a set number of AZs. Most have, I believe, at least 2 or 3 AZs. Some regions that are new, like Beijing, for example, still only has 1, and Amazon classifies those as quote-unquote beta, because you can't really do a lot of things that you would like to do in those regions. But again, Amazon's goal is to have at least 2 or 3 in every region. All of the AZs in the region, again, as I said before, are connected via high bandwidth, low latency fiber. So Amazon doesn't publish the physical distance between these data centers, but I would guess it's probably no more than 100, maybe 150 miles between these. And Amazon actually goes and lays their own fiber interconnects between these AZs. So this is another reason that the multi-AZ failover, for example, for RDS, works really, really well. So our primary database, may be experiencing a heavy load, but as the writes into that database are coming in, it's simply spreading those writes to the hot failover slave, maybe that we provisioned in AZC over here, so that if we did ever need to fail over, we can be sure, because this high bandwidth and low latency connection, we can be sure that our data is up to date if we did need to fail over, for example, to a slave. Some of the services, we said that most of the services, like EC2 and RDS, are provisioned at the AZ level. Some services, like S3, DynamoDB, SQS, the queuing service, exist in the region. And what this means is, for example, S3, the object store that Amazon uses, is simply, if you're familiar with the concept of an object store, it is just a place to put up a sequence of bytes. And those bytes could be a text file, they could be some PHP code, they could be you know, an image or a tar file. It doesn't matter. If it can be stored digitally, you can store it in S3. And when you provision an S3 bucket, you actually provision it in the region. And what happens then is that when you put an object in a region, it actually leverages storage nodes in many of the regions. So in at least 3 of the regions, it'll provision multiple storage nodes, so that we store maybe, you know, 4 copies of it in AZB, 2 copies of it in AZA, and I don't know, 4 copies or something in AZC. And we get this very nice, you know, almost impossible to ever lose data sustainability for that data. And things like S3, like DynamoDB, and like SQS, again, leverage multiple nodes, multiple storage resources in multiple AZs. So they're very, very durable and fault tolerant. The costs that you'll see when we flip over to the Amazon Web Console and we actually look at the individual costs, the costs for each of the services will vary slightly from region to region. And again, the reason for this is it's obviously probably much cheaper to get real estate and power and bandwidth in maybe Oregon or maybe even in Dublin than it is in Tokyo, for example. So certain regions have costs higher or lower than other regions. And you always want to check, if you're moving services into a region, you always want to check the costs for that region. They pretty much move in lockstep. When Amazon does a price discount across the board, they pretty much propagate that discount across all the regions. But some of them, you know, that may not be able to inherit that cost reduction. The default region when you begin using Amazon is US East, and you have to be careful if you are deploying into other regions. It's funny, I've had clients call me up kind of freaked out because, you know, their services are up and running, they know they're at Amazon, and they log into their console and they see 0 servers running. We'll look at this in a bit, but the console, the Amazon Web Console, allows you to flip into different regions. And what happened is those clients, you know, maybe flipped over to the Tokyo region where they have no services running, and they didn't see that they actually were in the Tokyo region rather than the US region. So when you provision services, they will be deployed either to a single AZ in a region or a region itself. You don't provision services across regions. Cool. If anybody has questions on the AZs or the regions, please feel free to send those over, and Michelle will be able to send any questions you might have. Great. So let's talk about the concept of edge locations. If anybody's ever worked with Akamai or another CDN or content distribution network, you're probably familiar with this concept already. Edge locations, you can think of them as lightweight storage areas. So these are essentially just a bunch of small little racks of servers that are peppered throughout the country in various data centers. And what this provides is the ability to put content closer to individual users themselves. So if we zoom out on this a little bit, and let's move over here, if we look at this user right here, let's call him Bob. If Bob is trying to access some content, if we did not set up a CDN with an edge location out here, Bob would have to maybe reach out. If we expand this out, we see that Bob's, you know, maybe somewhere in the Midwest, maybe even further out over here. He'd have to reach out possibly half of the country to get that content from the region itself, if maybe it was stored in S3. If we instead use CloudFront, the content distribution network, or use the Route 53 service for the lookups, the DNS lookups, we would then push this content out closer to Bob. So when Bob comes in to get that content, he's instead just hopping, into a server that's maybe in the town over or possibly even down the street from where he is, and he doesn't have to make this big jump halfway across the country and encounter additional latency from that. So the content distribution network and the Route 53 DNS product in Amazon basically push content closer to the users so that they have a more a peppier experience with your website. And again, the two services that Amazon uses for their edge locations is Route 53, the distributed DNS service. So whatever, for example, you see up here in my URL that I'm accessing Prezi.com, right? When I make a call to Prezi.com, the first thing my computer does is figure out where the DNS server is that serves up the Prezi.com record, because computers speak numbers and humans like to speak with words. So this allows us to put in domain names like this and have that translated to an IP address. And every time that a user accesses DNS, they're going to have to do this lookup. So if we push the DNS records out to these edge locations closer to them, even if we don't put any content, like JavaScript or HTML or video into the CDN, just that lookup of DNS will actually make their experience with our website faster. A really huge benefit to this, obviously, is to the edge locations, is not only that DNS, which is usually pretty fast itself, but it's more around the content distribution network, which in Amazon's case is called CloudFront. And CloudFront is a pull mechanism CDN. So when a user first asks for a piece of content, if I, the vendor, or I'm sorry, I, the customer, the Amazon customer, have set up a CloudFront distribution and pointed it maybe to an S3 bucket, when this user goes to grab content, that'll first hit this edge location. And the very first time, there's nothing there because nobody else has called for it. So the CDN will actually reach out, and this communication actually occurs over a faster network. Amazon has high-speed network between their edge locations and their regions as well. So even for quote-unquote dynamic content that maybe you would have to serve out of a server, the speed and actually the cost will be better with CloudFront, believe it or not, than even just using standard S3. So let's say we had some images and some JavaScript files and some static content that we wanted to expose to our users. We could set up a CloudFront distribution, point that distribution to an S3 bucket, and then every time that the first user requests that data, the edge location will reach out to S3, or we could even use an on-prem server. It doesn't have to be an Amazon server for the origin. And the origin will then send the content back to the edge location, and then when subsequent users come to hit that edge location, they'll pull just from the edge location. Obviously, we can also expire content, so we can make sure, let's say we had some bad JavaScript that made its way out into our production distribution, our CloudFront distribution. We can expire that content and then make it so that users, when they come back in, will have to go back through and access through the edge location and pull from the origin. We got a couple questions in here. I'm going to try to address those real quick. We got a question from, I'm sorry, it's Manu. I'm not even going to try to pronounce your last name. I'm sure I butchered horribly. Is it possible to load balance an application between AZ using a 3DNS service? I'm not familiar with what 3DNS is, but yes, you could certainly round robin. You can set up your DNS records to round robin across two individual servers. What's more common, and we'll see this in an architecture diagram, Manu, coming up, is to actually just have the Route 53 resolve to an elastic load balancer, an Amazon-side load balancer, and then balance the traffic across those independent AZs. Cool. Got another question from Manu. Can we relate AZ to a single data center in a traditional way? It absolutely is. That's a great question, yeah. And AZ is a data center, so it's not even relate. That's truly what it is. One more quick point on that. So here you see that we've got, AZ, A, B, C, D, and E. These are constructs that Amazon lays over on a per customer basis. So if I come in and I start using Amazon, it may, assign me AZA to be, who knows, a data center in, let's say, Philadelphia. Whereas when you come along and you sign up as an Amazon customer, it may assign that Philadelphia data center to AZB for you. So these are not set designators. There is no one particular AZA. The A through B or C or whatever gets laid on after the fact as you come in as an Amazon customer. We have a question from Deepak. Do regions have HA, or is it just that AZHA is available? We can do, if we zoom out here, and actually let's zoom out until we get another region so we can talk about this. We see that there's several regions in the West Coast in America, so let's zoom in and look at US West in Oregon and North California. We can set up a Route 53 with either latency-based routing so that it routes users to the closest region or AZ that they have, or actually it's on a region basis. Or we can also set up Route 53 to do region failover. As I said before, as I tried to allude to before, if we're going to do that, we have to spin up two identical stacks of resources, let's say in these two data centers, or in these two regions. And for most customers, it just doesn't really make sense. True, if all of your, even if there is, 100 or 150 mile separation and all of your data centers are in North California and they experience a huge seismic event, they have a bunch of earthquakes, it's possible, I guess, that they could lose all of their data centers. But it's highly unlikely that you will lose multiple data centers at once. And because the costs are so much more to do multi-region, most customers do just HA across AZs. And I think when we see an architecture diagram coming up here, that should make a whole lot more sense for you there, Deepak. Cool. And I see one more question I'm going to address before we move on. I've got a question from Sunny. What sort of data transfer among the data center is free of cost? Pretty much everything. So the stuff, it's probably easier to list the things I know of that do incur costs. And this is actually even inside the AZ, Sunny. So if we zoom in to a single AZ, we have the EC2 servers can also use something called elastic block storage, which is provisionable. You can think of it like a provisionable hard disk that you attach to the EC2 server. That data transfer, even if it's just inside the AZ itself, incurs cost. As far as AZ to AZ, I'm trying to remember. There's just way too much stuff to remember with Amazon. There's a small number of transfers, and I can't remember what they are. Yeah, I'm gonna have to. Let me see if I can come back to that, Sunny. I'm drawing a blank right now. Almost everything. I would say 90% of your data transfers, north of 90% of your data transfers between AZs are going to be free. So it's a matter of hunting down those handful that you are going to incur a charge on. And I do see one more question. Got a question from Stephen to please define the API. Stephen, if we could put that one in a parking lot, and I'll come back to that shortly. We'll actually walk through the web console with Amazon services, and I can show you how you can access the services both via the console and via the API. Great, but getting back here to the edge location, these edge locations are also known as point of presence or POP locations, and this slide is a bit dated. As of today, I think there are over, gosh, I want to say 50 POPs now out there in the globe. So in my little map that I drew here, the POPs are the blue dots, and we can see that there's a whole lot more of those. and especially I know in Asia as well as US. I know Amazon's been adding like crazy to those. So we have a set of regions in US North, or I should say in North America. So we have 3 regions that are available for public use, and we also have GovCloud. GovCloud is a more highly secure region. It's used mainly for ITAR compliance, and ITAR states that persons having physical and logical access to the servers must be US citizens, where there's no such requirement in the other 3 US regions. So US GovCloud was essentially created for the US government to meet their needs, and if you are a government customer or you're servicing government customers, you can get access to that data center. There's also one region in Europe called EU Ireland, again with many point of presence locations around there. An important thing to note for any customers on the call who may be working or actually have customers in Ireland, there's a whole lot more constraints around their ability to import and export data from their countries. Amazon guarantees that when you put data into a region, it will never leave that region. So for example, if you provision an S3 bucket in the EU region, that data will never, unless you're the NSA, will never leave that region. So Amazon guarantees that they can be compliant with the more strict European restrictions around that. There's also 3 regions in APAC that are fully available, fully GA'd, and there's one region right here, Beijing, just came online, I believe, in December, and they currently only have, I believe, 1 AZ, so they're not out of beta yet, but that region will be slowly filling in more AZs, and that will be, you'll see a little orange dot appear here pretty soon. And then there's one region also in Sao Paulo, Brazil. So again, if you have customers maybe that are strictly in South America or in APAC or in Europe, you could leverage one of these additional regions to put contents more close to them. If you did have more questions about this, you can always browse this URL, and you can always get to this bit.ly as well through the slides. You may want to bookmark that as well. Great, let me check the questions list, see if there's any additional ones. Let's see, there's a question here from Manu. In case of AZ level HA configured, will Amazon take care of the data replication between the AZs free of cost? Yes, up to the point of free of cost. With RDS, for example, you can provision a hot standby slave for example, for MySQL, and that standby slave will incur additional cost. But it is actually, in the case of MySQL, it's a synchronous replication, so you're absolutely guaranteed if the data write happened in your master database, it definitely happened on your slave as well. But yeah, the additional cost is what you end up paying for. That's on the database side. On the, for example, on the web server or on the application server side, it's actually it's actually free to set up HA across multiple data centers, multiple AZs. And we'll actually have a slide that we get to here shortly that talks about that. Before we get there, let's actually walk through. This might be pretty aggressive in the next 15 minutes or so, but I'll take the best swing I can at giving you a couple minutes on each of these services. These are probably the most commonly used services that you as an Amazon customer will trip across. And kind of the gateway drug in Amazon for a lot of customers is S3, the simple storage service. Again, S3 is just a object store. It's a distributed object store. So they leverage, again, multiple nodes inside of multiple data centers inside of a region. And when you put a piece of data into S3, there are multiple replicas of it created and then peppered throughout those AZs. And if an AZ went down, or if a particular object on one of those nodes encountered bit rot and it went stale, you have several other copies of it laying around. So S3, probably the biggest thing about it is it provides for very high concurrent throughput. So because I've got maybe 12 or 15 copies of my data laying around on several nodes and several data centers, when multiple users come to request that popular content, they are pulling it from 15 locations rather than just one single disk head trying to serve all that traffic up. So it's very performant for highly concurrent, or sorry, I should say concurrent high throughput, and it's also extremely durable. We see this with SQS and with DynamoDB as well, because multiple copies of an object are peppered throughout multiple locations. It's very, very durable. And if we lose one or even multiple copies of it, or even an entire data center, we still have that data laying around. So Amazon S3 actually provides for 11 nines of durability, which is pretty much off the charts. Basically means if I have 10 million objects that I put in S3, I could possibly lose one of those per year. And most of us, I don't think, have 10 million assets that we put up in S3. S3 also has, like all the other services, has several facets to it. We can do encrypted data. We can store our data encrypted by default at rest. We can get a lower number of nines. We can get 4 nines with RRS, reduced redundancy storage, and pay about 30% less for our storage cost. And a whole bunch of other cool stuff. We can serve websites out of S3. We can set up notifiers so that when an object degrades, it kicks off. If we did lose one of those 1 per 10 million objects, we can kick off a notifier that says to go recreate or repull that object and put it back in S3. EC2 is the service that probably most of you are familiar with. It stands for Elastic Compute Cloud. It is essentially virtual servers. So these come in now, I think, 30 different instance types. So an instance type provides for the hardware footprint of the machine, and that's things like your RAM, your CPU, the number of CPUs available, the amount of network and disk bandwidth that we have available, and also ephemeral disks, which are attached disks to that EC2 instance. Folks use these, obviously, to spin up their applications. So if you're running code, PHP or Python or Ruby or Perl or something, you probably have that running on an EC2 instance, or preferably multiple EC2 instances balanced in an auto-scaling group across multiple AZs. And we'll talk about that diagram in a second. Elastic Block Storage, as I alluded to, is that sort of provisionable disk that we can provision and then attach to a single EC2 instance at a time. Logically, you can kind of think of EBS the same way that you think of like a 3.5-inch hard drive. You go down to Best Buy, you buy a 2 terabyte hard drive, you plug it into your server, you format it, and then you can start writing information to it. It's the same thing with EBS. You provision a disk of a certain size, you attach that disk to one EC2 instance at a time, and then from that EC2 instance, you can format the disk, mount it, write to it, so on and so forth. This is highly mirrored. This is, again, highly durable. So when we create an EBS volume, there's actually internal mirroring that happens. It has the ability also to be snapshot, so we can snapshot this data and take maybe two snapshots of it a day and be able to roll back to a given point in time. Unlike ephemeral disk, which is attached to the EC2 instance by default, EBS is the data on an EBS volume is independent of the life cycle of the EC2 instance. So we can provision an EBS volume, attach it to an EC2 instance, write a bunch of data on that volume, and then kill the instance, and the data is kept around. The same way as your 3.5-inch hard drive in your server would persist if the server went away. Something that's always hard for folks to get their head around if they're coming from a traditional data center is the fact that we're expecting these EC2 instances to come and go a lot. We want to have this sort of curve. Let's just maybe draw a line here. We want to do something. Oops. Let's see if I can get a pen going here. There we go. So if our usage curve on our website looks like this on a daily basis, we want to provision a low number of servers at night and then slowly start adding EC2 instances. As our demand starts increasing around lunchtime, there's always a little saddle right here, and then we want to start taking those servers away on the other side. So the fact that these EC2 instances come and go is something that we want to embrace in the cloud, and we want to, instead of provisioning this maximum capacity plus a little bit of delta, we're constantly just keeping ahead of our usage curve, and hopefully never going into a scenario like this where there's more demand than actually supply. The Elastic Block Store we talked about, RDS is just a managed database service. So this allows us to provision MySQL, SQL Server, Oracle, and now, as of November last year, Postgres as well. And with any managed service, we don't get direct access to the box itself, but what we do get is the ability to easily stand up a database and easily do things like backup, like HA. We can even, in the case of MySQL, do read replicas, and we can, scale out our read operations from the database. Elastic Load Balancing Service is essentially, I'm 99% confident, it's just, again, on top of EC2 instances. Amazon created these little load balancers, and what these do essentially is just balance traffic across 2 or more EC2 instances. So when a user comes in to get a piece of content, the load balancer will direct them to one of the EC2 instances we have in the backend. And again, this can be very useful. For example, if we're doing that multi-AZ setup on our EC2 instances, our load balancer can even balance traffic across 2 data centers. And then if we completely lose one data center, we just spin up capacity in the other data center. And these last 3 services, Elastic Load Balancing, Autoscaling, and CloudWatch, are essentially what Amazon refers to as the triangle services because they work really, really well together. And Autoscaling Group is something we create to span capacity typically across AZs. We could do it inside of a single AZ, but it makes a whole lot more sense to do it across multiple AZs. Autoscaling applies only to EC2 instances. So we essentially create an autoscaling group, and then we put EC2 instances into that autoscaling group. And then the group itself can be configured with, for example, a minimum and a maximum and a desired number of servers, and it will always try to maintain that number of servers. So if we, for example, if we specify some folks even do this for a single server, in case you want to make sure that that server is up, even if the data center that it was in went down, you could specify a maximum and a minimum of 1, and then span the autoscaling group across 2 AZs. And if we lost the AZ that it was currently in, the autoscaling group will take care of spinning it up in a second AZ that you set up at autoscaling group provision time. More commonly, we're doing something like I drew here in this horribly drawn web curve diagram, where we're trying to dynamically add and remove capacity based on user demand. And for that, we need to fire alarms, and that's what CloudWatch is for. CloudWatch is essentially a monitoring and alarming service that can watch various parameters of Amazon native services. So we could, for example, watch the number of requests coming into the ELB, and based on the number of requests, add or remove, or I should say, fire an alarm, which will add or remove instances in an autoscaling group. So this is how we achieve this stair step, is by basically pre-setting up alarms and saying, maybe for the ELB, every time that we see an additional 5,000 requests, we know that we need 2 more servers. And we stair step up like this, And then on the other side of it, we essentially create our alarms in pairs. On the other side of this, we know that every time that we lose 5,000 requests, we need to remove 2 servers. So setting up an auto-scaling group, CloudWatch alarms, and an elastic load balancer will ensure that we automatically move these servers into rotation, and then the load balancer auto-registers and starts automatically balancing traffic across those. And to tie this all up into a single diagram, this essentially discusses all of the services and a couple more that we've been talking about. So up here at the top, you see that we have an elastic load balancer, and we've told that load balancer to balance its traffic across 2 AZs. So we have AZ1 or AZA down here, and AZ2, AZB. We can also, go out to 3 or 4 or 5 AZs if we have that many available in our region. Inside of each of these AZs, we've set up a web server, and we've set up an auto-scaling group. And in reality, this auto-scaling group kind of spans across these AZs. So the auto-scaling group is maybe set up with a desired capacity of 4 servers, and it will spin up. It knows that it's spanning across 2 AZs, so it will spin up 2 web servers in each side. And if we were to lose the AZA over here, the auto-scaling group would automatically spin up 2 instances in this AZB to take care of that capacity, so that we're constantly trying to achieve the number of servers or EC2 instances up that we need at any given time. You can see that inside of these servers we have CloudWatch alarms installed, and this is probably what is controlling our scaling of our group. So that again, if the load balancer starts getting more requests, or if the latency starts going up, we can start adding additional instances inside of here. We could also do it based off of EC2 metrics, so maybe the aggregate CPU of our auto-scaling group. If that goes over 80%, we want to add more instances, and if it goes below 20%, we want to take them away. We could also create alarms based on custom metrics. So I could, for example, maybe in my application, the number of threads that it has open is a big indicator of when I need to scale. And I can create those custom metrics and fire my Amazon side alarms for my auto-scaling group based on those custom metrics. So here in our auto-scaling group, after that we have maybe a software load balancer. We could also now throw in, if we were using virtual private cloud, we could also throw an elastic load balancer in at this point as well. What this allows us to do is loosely couple our traffic so that the web servers aren't tied to just a single app server. You're going to be thinking of any of these machines coming and going at any time. And if we lost our app server down here, we wouldn't want this tight coupling. So we instead go through a load balancer. Here we provisioned our own, and this load balancer again directs traffic across an auto-scaling group inside of this AZ. And then here you see that we're connected to a master and slave RDS database. Again, the master will continue running and doing synchronous writes to the slave. So every time that it's recorded a record in its database, it's verified that the slave has it as well. And again, with RDS, this is simply doing a checkbox. All we have to do is say, I want to use a slave in another AZ, and it spins up the resources for that. And then if we did, for whatever reason, lose the master, it does a virtual route instead then to the slave, and the slave becomes the master. And we can spin the master back up, or to be honest, we could even put it in another AZ if we chose when we spin it back up to deal with that HA again. Here you see that we've got a couple things stored in S3 as well. We've got static content, and maybe we're also doing backups from our code and our database. Maybe we're taking the deltas or doing a full database dump and dumping that data in S3. S3 is actually very cost effective as well, and it's, although the assets inside of it are natively accessible via the web, the access rights is is locked down to only the individual who wrote that data. So doing things like backups is totally secure. Nobody's going to be able to go in and grab your data unless you open that up. Here you see that maybe for responsiveness, we've also set up a CloudFront distribution, and we've backed that with an S3 bucket, and maybe we're also using Route 53 to provide our DNS lookups in a more peppy fashion than using another service provider. Great. That is pretty much, oh, the other thing I wanted to go through was the AWS Management Console. So a couple folks asked questions. There was one question about what is an API. When you sign up with Amazon, let me make sure this is still live. I haven't been logged in a while. Okay, still got me logged in. This is what you'll see when you first log in via the web console. And we can, for example, go into the EC2 tab, and I could provision a new instance. As I said before, the instance type, let's actually pick an AMI first, and we'll talk about the instance types. The instance types break down into various families with various costs, and I can pick one of these, and I can launch an instance through the web GUI. The web GUI is probably at this point maybe, I don't know, 60, maybe 70% of all of the features possible. When we talk about Amazon Web Services, the services themselves are mainly REST services. So I could also spin up an instance by passing my credentials to a REST call, and that call will actually spin up the service as well. So everything in Amazon is an API, and once I get credentials to go in and start spinning up services, I can fire off these API calls and do the same thing that I could do through the web GUI. So 100% of the features that Amazon provides are given to us via the REST API, and maybe, it's hard to say because they always keep changing it, maybe 60 or 70% of the features are available through the web GUI. But again, it's most of the common things that you'll be doing. Here you see that we have the ability to spin up load balancers, to create security groups, these little stateful firewalls that we wrap around instances. We can create auto-scaling groups. We can create RDS instances. We can create S3 buckets. Most of the stuff that you'll be doing on a day-to-day basis, you can do through the web GUI as well. And one other thing I wanted to say, I think I forgot to mention this. I said that the instance type is the hardware footprint. We also have on EC2 the software footprint. And these are what are known as AMIs, or Amazon Machine Images. This is Linux or Windows based operating system, and possibly some additional software on top of that. And a really cool thing, let's actually go to Marketplace. Amazon offers a marketplace where I could go in and, let's say I wanted to experiment with MongoDB or WordPress or something like this. I can go in and spin up a AMI that uses the service that's listed here and may incur additional cost. So the AMI itself is the software footprint, and an AMI can be deployed into, as long as the instance has enough storage capability, can be deployed into any instance type. So the hardware footprint and the software footprint for EC2 are two different things. Cool. I've been running along at a breakneck pace here. Let me see if there's any additional questions. I'm sure there's a couple that came in. Yeah, quite a few. So Deepak has a question. What about sharing AMIs across regions? I believe that is possible now. I think you can back it up. I know for sure it used to not be possible, but I think you can now ship an AMI to another region. Each AMI in a region will have a specific designator. So for example, here you see that I'm in the Oregon region. This AMI ID is going to be very different than the exact same AMI. Let's actually look at it. Let's go to, so this one ends in F88, and if we go to maybe North Virginia instead, and look at that same AMI, see it's a different ID. It ends in 546. So the AMIs themselves are different numbers across the regions, but you can now, I believe, create an AMI and easily ship it to another region, and then use that same AMI in another region. Again, that's a pretty uncommon thing to do, but if you did have that use case, I believe it is possible now. Simon Knight has a good question here. I've looked at whether to move from a traditional DC to AWS before, but found it very difficult to figure out how much AWS would cost per year. That's a really good point. Yes, there is a fantastic tool that helps you figure that out. And if we go to, you can just Google AWS pricing calculator, which is what I always do. And you'll see this simple monthly calculator. You can always go into this calculator, and if you know what your usage is, if you know how much bandwidth and how much storage and so forth that you're using, you could go in, let's say, for example, on the, let's just say on EC2. I can go in and say, I know that I do, whatever, 500,000 gigabytes per month, and I need, I don't know, what am I even doing here? It should have, it's not showing me an option for EC2 instances themselves. Let's actually pick something maybe more simple, like S3. And let's just say that I'm storing, the same amount, 50,000 gigabytes, and I plan on doing, 100,000 requests per month, and I know that my data transfer currently is, whatever, 1 terabyte per month. Every time that I updated this, I don't know if you saw, this estimate of the monthly bill increased. So I can slowly, play with this and see what the various changes to this impact the monthly bill. So it is pretty easy to go through with this pricing calculator and figure out what your costs will be ahead of time. And Amazon does break their costs down very granularly. So we see here with S3, it's not only the storage and the data transfer, but it's also the number of requests. And the reason Amazon does this, it's an excellent reason, is they don't want to penalize any individual customer and just sort of make a baseline that everybody has to fall into a plan. Because some companies may not transfer a lot of data, but they may store a lot of data. Some companies may not store much, but transfer a bunch. And the way that you use the service, Amazon wants to charge you only for that. So it does make sense. They are kind of being nice by making the pricing model complex. I think I'll do one more question here and hand it back to Michelle. We've got a question from Sharon Dooley. Does Amazon service include patching and upgrading operating systems? Ooh, that's a really good question. On the EC2 services themselves, you're responsible for managing from the OS up. So you're responsible for patching. In fact, the first time that you spin up a Linux instance, for example, if you run a Yum update or an aptitude update, you'll see a whole bunch of packages that need to be installed and updated. Amazon they do make new AMIs on a periodic basis, but they're not going to go into your server. They actually cannot even get into your server to make those updates. Now that's on EC2. For RDS, for example, let's flip over to that tab. You do have the ability, let's say launch a DB instance here. You do have the ability here's where you specify multi-AV deployments. And I'm hoping to get to this next page. Hope it doesn't. The database spin-up can take quite a while, obviously, so this may have taken too long. For RDS, the database patching and upgrading is handled automatically. So any managed service is going to take care of that for you. But EC2 itself is not going to manage that. So if you're using MySQL in RDS, it'll take care of that. It'll take care of the patching. Cool. I think that's about all we have time for. I hope you guys found value in this. I'm going to go ahead and pass it back to Michelle to let us do a final wrap-up. And happy to answer questions offline if you have additional ones. I think Michelle has some more information about courses that we offer, Global Knowledge. I think our Amazon courses are fantastic. They basically go through the exact same materials. It's not even basically, it is. They go through the exact same materials that Amazon provides. We actually use the same materials, and we go through the same training procedures that Amazon gives to their individual instructors for their company. So we've got several courses there. Michelle, did you want to lead us out and tell folks some more about that?
Yeah, thanks so much, Rich. We will try and get the questions that were not answered to you guys individually after the presentation is over. But yeah, I think we're just about out of time. So thanks so much, Rich, for a great presentation, and thank you all for joining us. Be sure to check your email in the next few days for a link to the recording of this webinar. So hope everybody has a great Friday.